Okay, so for this question, I'm going to take the infusion rate at 1,000 units per hour. That's fine. I meant to put this over here. And I don't want units per hour. I want milliliters per hour. So I'm going to take the given, and my given is the 1,000 milliliter IV that has 25,000 units of heparin in it. So I'm going to put units on the bottom, milliliters on the top, 25,000 units on the bottom, 1,000 milliliters is my IV. Then I'm going to multiply 1,000 times 1,000 divided by 25,000, and that'll be my answer. So 1,000 times 1,000 divided by 25,000 will give me an answer of 40 milliliter per hour. The alternative way of doing this question is to start with, you know you're looking for milliliters per hour. So you want milliliters in the numerator. So you start off with your IV bag of 1,000 milliliters, and it contains 25,000 units of heparin. Okay, so those two numbers need to stay together. Okay, then you multiply by the infusion rate, whatever that happens to be, and that will give you the same answer of 40 milliliters per hour. So again, this is question 22 on the practice test for 220, 230. Question 23 is going to have a similar setup. The only difference is we're using smaller numbers and we're using insulin instead of heparin. So it says 500 milliliters IV Humulin R, regular U100 insulin, 500 units to infuse at 10 units per hour. So I could set it up both ways like I did here. I'm just going to show you the one way. I start with, since we're doing a conversion for flow rates, I start with the flow rate, and then I just convert that flow rate into what I want it to be, milliliters per hour. So 500 milliliters, 500 units, and that will equal 10 milliliter per hour. For 24 is just a step back, and it's kind of like regular flow rate type question, where in this question, we're going to ask, how long is it going to infuse for? If it starts at a certain time, when does it end? So we have 1,000 milliliters. It's infusing at 50 milliliters per hour. And that will give me a 20-hour time in which it's infusing. So if it starts Monday at 8 a.m., I want to know when it will end. And so what you can do is, that 24 hours from Monday at 8 a.m. would be Tuesday, 8 a.m. If it's 20 hours, just subtract 4, and it would be Tuesday at 4 a.m. And that's how you would answer 24. So let's do the Heparin protocol. The thing that's tricky about the Heparin protocol is that you really haven't seen the Heparin protocol outside of the practice tests and practice information. So let me pull up that so you can see what that looks like. Okay, and get this to stop pulsing, that would be great. Sorry. Okay, so the Heparin protocol, what I have kind of put in this box here, that's the Heparin protocol. The trick to this is, it's really not a trick. It's just knowing that when we say Heparin protocol, we just mean following like these steps and then knowing what to kind of include and what to exclude. So the first thing is you're going to be given the patient's weight in pounds. So you need to convert the patient's weight in pounds to kilograms. Then you just need to know kind of what information you're going to use from the Heparin protocol. There's a bunch of different steps. Some of the steps are not important, like where there's these blanks. Instinctively, you want to fill in these blanks, but you don't need to. That would just be filled in. There's probably different procedures and protocols that are specific for what the hospital recommends or the clinic recommends in regards to following the protocol. What's important is being able to kind of look at this and then find the information that you need in order to answer the questions. The questions and what you'll see on your actual test will come down from down here. It says, answer the following questions. Now, on your test, you will only have to answer 2 of these, meaning A and B or C1 and C2. You won't have to answer all 4 of these questions. You would only answer 2 of these questions that are listed here. Okay. So if you're wondering like, man, why is there 4 questions here? I did that on purpose to give you additional practice. Okay. The other thing is, and I'll give you an example. The only thing I can really change on the test is the patient's weight, right? I can make them a different weight. And then that would change all your answers. But obviously that would make sense because it's a different patient, right? All right, so let's just work through this because I think that's the easiest way to kind of navigate how to get through this particular question. So we'll start off with the converting the patient's weight in pounds to kilograms, which I think most of you already know how to do. So this is the Heparin protocol. Patient's weight is 110 pounds. I'm going to convert that to kilograms by dividing by 2.2, and I'm going to get 50 kilograms. Okay. Now, question A says, calculate the number of milliliters to administer for the bolus. When they're talking about this, they're meaning the initial bolus. The initial bolus is what we're supposed to do is stated twice. It's stated at the beginning of the protocol where it says bolus patient with 80 or with heparin 80 units per kilogram body weight, and then start a drip at 18 units per kilogram per hour. And then that same information is also going to be in step 10 of the protocol. Bolus with 80 units per kilogram, start drip at 18 units per kilogram per hour. So again, if you do a Google search for Heparin protocol, you're going to see essentially what I have typed up here for you. All right. So we're going to take the patient's weight and we're going to multiply by the 80 units per kilogram in order to calculate the bolus dose. 50 times 80 is 4,000 units. Okay. Now, if the question had said calculate the number of units to administer for the bolus, we would be done. Unfortunately, it says to calculate the number of milliliters to administer for the bolus. So we need to account for that. So I need a way, I need to have a way to convert units to milliliters. And thankfully, we have the Heparin protocol to kind of help us out. So in step 2 of the Heparin protocol, it says 25,000 units in 250 milliliters, half normal saline, and then bolus dosage strength, 1,000 units per milliliter. And I know the screen's a little bit blurry, but hopefully you have a copy of this available to you. All right. So what I'm going to do is I'm going to take the bolus dosage strength. The bolus dosage strength, remember, was 1,000 units per milliliter. And where did I get that from? Step 2 of the Heparin protocol. So I don't want units. I do want milliliters. 1 milliliter, 1,000 units. And my answer is 4 milliliters. So I would administer a 4 milliliter bolus dose, and then I would start them on the IV drip. Now, in order to know what to program the infusion pump to, that's where the next step comes in. So part B says, calculate the infusion rate in milliliters per hour for the heparin IV drip. So same patient. The protocol says to start them at 18 units per kilogram per hour. $50 times 18, plug that into the calculator, you will get 900 units per hour. Again, we would be done if it asked how many units per hour, but it asked to calculate how many milliliters per hour. So in order to know the milliliters per hour, I have to go to my IV bag. My IV bag has 25,000 units in 250 milliliters, half normal saline. Notice that there's also the bolus dosage strength. We only use the bolus dosage strength for bolus dose questions, and we use the IV bag for infusion rate questions when it comes to the heparin protocol. So I'm going to take, I don't want units, I do want milliliters. There's 250 milliliters, and within that is 25,000 units. Now, you've probably seen this on some of my other videos. The ratio here is 1 to 100. Okay, so just something to keep in mind if you're ever trying to do this quickly and just making sure you're checking your answers. Just know you just take the patient's weight times 80, and then whatever that number is, divide by 1,000. Patient's weight times 18, whatever that number is, divide by 100, and then that's a quick way to answer these questions. So this would be 9 milliliters per hour. For C part 1. So C tells us some new information. It says after 6 hours, the patient has an APTT of 43 seconds. Okay, so the boxed section is where we apply any information pertaining to the APTT. So we look at and we say, okay, 43 seconds, where is the range associated with the 43 seconds? Well, step 12 of the protocol says if the APTT is between 36 and 44 seconds, then you follow these new steps. So that's the other thing that can change on the test: patient's weight, the APTT. And then regardless of what they do, you just apply the information, and you'll be given this protocol. I guess I should tell you that too. This is not something you need to memorize. Although if you do it as often as I've done it, you probably will get to that point where it will feel like you've memorized it. But anyways, so 43 seconds. So it tells us to do some things. It tells us to rebolus with 40 units per kilogram, and then to increase the rate by 2 units per kilogram per hour. And that's what this says. Calculate the number of milliliters per pair for the bolus and calculate the new infusion rate in milliliters per hour. So let's do that. So same patient, 50 kilograms, new bolus, 40 units per kilogram. Okay, so notice that 80 or 40 is half of 80. So my expectation is that my answer is going to be 2 milliliters. We get 2,000 units. Again, I don't want units, I want milliliters. And so I'm going to use my bolus dose strength, which comes from step 2 of the protocol, which tells me I have 1,000 units per milliliter of heparin. And then I will get 2 milliliters as my answer. For C part 2, it says in the protocol, it tells me to increase my infusion by 2 units per kilogram per hour. What was my initial infusion? My initial infusion was 18 units per kilogram per hour. So 18 plus 2 That's your new infusion. So 50 kilograms patient weight times 20 units now. And then you'll get 1,000 units per hour. Again, I don't want units per hour. I want milliliters per hour. What does this 1,000 units per hour look like? Remember question 22, when we were converting heparin, infusing at 1,000 units per hour, and then we were converting it to milliliters per hour. That's why I said question 22 is basically how you do part B, part C2 in these heparin protocols. So we use the bolus dosage strength to calculate the bolus dose. We're going to use the IV bag to calculate the infusion rate. So the 250 ml, 25,000 units. Remember, that's the same thing as 1/100. So my new infusion rate would be 10 milliliters per hour. The first time when I was learning how to do these, I rationalized the 4 to the 2, and that made sense. And then I confirmed it with my math. And then when it said to increase the infusion rate by 2, I was like, oh, okay, the answer is going to be 11. But then if you read that closely, it says 2 units per kilogram per hour, not by increasing by 2 milliliters per hour. And so that's why it's important to work through the steps here as they're laid out. So that's how you would answer these questions. And again, you're either going to get these 2 or these 2. You won't get all 4. Okay, it's like practice to do both of these, which is, I think, good practice. So let me show you an alternative question that you won't see on your practice tests, and it's going to be unique for you guys. And what I'm going to do is I'm going to give you a new patient's weight, and then I'm going to give you an APTT scenario, and we're going to work through it. Or I guess I should say I'm going to work through it, and then you can do the same thing on your own. You just basically choose patient's weight and APTT and then work through it. So again, this is another heparin question. What we're going to do is we're going to say we have a patient that weighs 178 pounds. Okay. They're already on an infusion, and we're going to check their APTT after 6 hours, and it is going to be, let's just say it's going to be 32 seconds. Okay. Then I want to know what is bolus in milliliters, and then what is my milliliters per hour given that information. Okay. So before I do anything, I got to convert the patient's weight into pounds into kilograms. So I'm going to take the 178 and divide by 2.2. And I'm going to get 80.9090. And that's repeating. And I'm going to round that to just 80.9. So I'm rounding it to the nearest 10th. I'm going to go to my protocol, and for an APTT less than 35 seconds, so what did I say? 32 seconds. I'm going to rebolus with 80 units per kilogram, and then I'm going to increase the rate by 4 units per kilogram per hour. Remember, the original was 18, so increasing by 4, it's 18 plus 4 would give you 22. So for the bolus, I'm going to take the patient's weight in kilograms. I'm going to multiply it by the bolus dose strength, which is the 80 units per kilogram. And I'm going to take that 80.9 times 80. And I'm going to get 6,472 units. Keeping in mind, I don't want units, I want milliliters. I'm going to use the same bolus dose strength, 1 milliliter, 1,000 units. And I'm going to get 6.472 milliliters, and I'm going to round that to 6.5 milliliters. Sorry, I'm running off my page here. That's supposed to be 0.5. So 6.5 milliliters for the bolus dosage strength of this new scenario. For the infusion rate, again, same patient, 80.9 kilograms. And I'm going to multiply by the new infusion rate. Remember, the original was 18. We know it was 18 because it's stated in the protocol, and then it told us to increase by 4. Okay. So 18 plus 4 is going to be 22 units kilogram hour. And 80.9 times 22 is going to be 1,779.8 units per hour. I don't want units per hour, I want milliliters per hour. So again, I'm going to go back to the protocol. Remember, I have the 25,000 units of heparin in the 250 ml of half normal saline. And that relationship is still 1/100. So I'm going to divide by 1. And I'm going to get 17.798. That would be milliliters per hour. I'm just giving this a second because the internet started to slow down for some reason. And I'm going to round that to 17.8 milliliters per hour. Okay, so if you have any questions, go ahead. You can unmute and ask. If you have a specific number you want to see worked out, you could just type it into the chat, or again, unmute and ask. And if you feel pretty good about these things, just want to practice some more and get together with me again on Thursday, that's also an option. And then this has been recorded and I will post it on YouTube either this evening or tomorrow.
Dr. Ray, I have a question.
Yeah.
So for C part 2, for the 20 units, how did you get that? Did you do the 40 divided by 2?
No.
Okay.
So remember, it says increase the rate by 2 units per kilogram per hour. What was my original units per kilogram per hour?
40.
No.
18.
18.
Oh, 18. Okay.
Yeah.
18.
Yeah. So
okay.
Yeah, because that's where we started, and then we're saying to increase it by 2.
Okay.
And so that's why 18 plus 2 is 20.
So we're going back to part 10, basically.
Correct. Yeah. So we're always going to relate everything to our initial thing. So like when it tells us to rebolus, you don't need to worry about it. You just follow what it says to do in the rebolus. But when we're talking about the rate change, always remember they're already on an IV. They're already receiving heparin. We're just wondering, are we going to increase it? Are we going to decrease it? What are we going to do? Are we going to continue what we're doing? What are we going to do?
Okay.
Yeah. Good question. And like I said, I know when you're initially looking at this, it's like, wait, what do I do with these things? And I think that's interesting that because you were the second person that mentioned like taking that 2 and like dividing it. But I'm hoping that I clarified why we got to 20, because if we did like when I gave you the other scenario with increasing the rate by 4, so I didn't do 80 divided by 4 because that would have been 20 as well. I did 18 plus 4 because that's what that's pertaining to. It's the drop rate or the flow rate, 18 units per kilogram per hour. I increased it by 2 or I increased it by 4, and that's where those numbers are coming from.
Insulin.
Yeah.
So I understand that the total is 50. Now, when it's asking you to mark the arrows, is it just basically asking like where would you mark the regular and then the NPH?
Let me show you what that looks like. Because on a paper test, yeah, I do think they're starting to get away from this question. So on the pages that I've shared, or the OneDrive, the questions that I've shared, there is a little bit more. You can see I took a photocopy of the book that I got this information from. So what's important to note is that you know which one to draw up first, regular first, and then that you can mark the total on the syringe. And that's usually what they ask you. But if they ask you to also mark where the regular insulin is, a lot of times what they're asking you to do is just to denote the fact that you drew the regular first. For the regular insulin, the 10 units of regular, it would be between 40 and 50. And then the NPH would be pushing that regular towards the total. Now, in reality, and if you haven't done this already, or if you have done this, you can verify it. If you haven't, what you're going to find out is when you draw these 2 medications up, they mix together. That's the whole reason why you're drawing the regular first anyways, is because it's clear and then the NPH is cloudy. That way you have a way to differentiate. And so they all mix together. And then obviously when they get injected, then they're both going in, simultaneously. And that way you get, I guess, instant action plus a little bit of a delayed action as far as an insulin response. But this is typically how they want you to answer that if it's on a paper test. And then I would just confirm with your instructor how they want you to answer this particular type of question.
Okay.
Yeah. That's good. So 200 milliliters to ounces. So I'm going to do 200 divided by 30. And then, yeah, you get the 6.6 repeating. And yeah, you would just round to the nearest 10th of 6.7 ounces.
Okay.
Yeah. So when you're going from metric to non-metric to American Standard, you can round to the nearest 10th if need be. And then when you go from, pounds to kilograms, definitely round to the nearest 10th. And then when you're going from milligrams to grams, micrograms to milligrams, do not round your conversions. 125 micrograms is equal to 0.125 milligrams. Don't round that. Okay. 1,275 milligrams is equal to 1.275 grams. Again, don't round that. Leave it. That's how, when you do metric conversions, you keep them. You don't round those. Okay.
Okay.
And those are called inter-unit conversions. So do not round when you're doing inter-unit conversions.